of model airplanes. Well, it really is. And every time we go to feed the bird, we have to remind my friend Peeps that Freddy's stuff is off limits. And having said that, let's go to the windy video. It's amazing how entertaining these birds can be, but we have shop projects to work on. We have never been busier and never had more fun. You see, here you are, you can buy a real B-25, a poultry 25 million. Who knows how much it is. Never get sick of that B-25. Chicky, he's still here. He came for a very short babysitting vacation, and he's basically taken over our whole life here. And it's so much trouble keeping him quiet. Freddy, you've got to learn to be quiet and not bite. Look with the feet. No, no, no. You bite me, I'll pull your nose. Anyway, off to the shop. There's never enough bird action in this shop. As you can well imagine, the flying season is well underway now. Guys have been at the Powell Park site pretty much all week. And we've got a few interesting things that I'd like to go over as one of the things that would probably be a big help when you trim your next plane, or planes that you already have. Now I call this part of the tape, and we've tried to include some of this on most of the tapes. These are the questions that get asked over and over and over and over and over and over again. And so what I've been doing is I've been recording what these things are, and so when somebody in a club or somebody calls and they have one of these typical problems, well, it's a lot easier to solve it this way than with a 2-hour phone call, and somebody might not remember, and a week later they forget, and, well, this has been an efficient way of helping people. Now, when I get a call, and this is what inspired me to do this right now, is a person has a Cardinal, and the problem that they want to solve is the plane yaws. Now, what actually is the yaw? Let's define what the yaw is. The wind should be blowing or could be blowing from this direction. As you come into the wind, and I'll use the pen as an example, as you come into the wind, the plane would typically yaw away from you, and you could see the wing from the pilot's view. You can see it doing this. Not sure the judges really see this as much as you think they do. Probably you could get away with it. And when it's down here, now picture the worst of all worlds, it's because more side area is almost always in the back of the plane than the front, it tends to pitch in at you. Well, we call that a yaw problem. I call it a yaw problem. It's really called weather vaning. I call it a yaw problem. And these are the things that can make that happen most often, the most common ways to solve them. Now, the reason having this on video is so helpful, I think it's so helpful anyways. Here's the scenario. Somebody has a plane, like what we're trying to work on now. The plane yaws. Well, what would be some of the things? Well, now I try to list them in the order that would be the most common cures for this. These are not always instant cures. The most likely culprit here, and a way to get rid of it, is to try using a little less tip weight. Now, what I do, one of the possibilities, is somewhere in the flight, and usually it'll be, and let's define this, top of the hourglass, and in the overhead 8, somewhere it gets soft. Now, typically it'd be right here that the plane will get kind of free flighty. Well, if you don't have enough tip weight. But if you have too much tip weight, you can figure out how to go about this backwards. Take a 1/4 ounce out at a time until it does get soft up here, and see if that cures the problem. Well, you know that when it does get soft, put back 1/8 of an ounce. So you can kind of narrow it down to the point where you have what would be the optimum tip weight. Same thing in the overhead 8, and typically on the outside part of the overhead 8, because of the side area function of the plane, usually what happens is it'll want to lose tension in the outside part. So the same thing. Now, the reverse is true. If you're having problems, you need to add tip weight, or hopefully add tip weight, until these problems go away. So you're always balancing it. Gee whiz, if you didn't have to balance it, everybody would have 5 ounces of tip weight, the plane would never come in at you, and it would be yawing for the whole flight. Well, pitching, yawing, whatever you want to call it, it would bang a corner. A lot of people do this differently, and it's been written about that. You'll do a triangle, and in the last corner, if it doesn't drop the tip, you take out tip weight until it just holds the tip. That's almost the same as this. You can pick however you think is the most realistic way to do it, but I always like to have as much tip weight as possible without getting it to the point where the plane is yawing and dropping the tip. So I'm always balancing it. When you're working this kind of a problem, it may be that somewhere down the road you want to have your hinge lines untaped, but during the trimming of the plane, taping them does 2 things. The first thing, it'll always allow you to carry just a bit more tip weight because you have sealed surfaces, and in essence you have more lift on each wing. But what you have is equal lift. Now, if, for instance, this would be the worst scenario, is to have a loose hinge line on the outer flap. This hinge gap is 1 or 2 or 10 thousandths more than this one. Now you wouldn't be able to carry even the right amount of tip weight, and it would be a problem. So by taping them, the first thing you do is you get yourself to a point, and I have never found any downside to taping planes. Everyone is taped all the time. Whether it's the B-25 or Miss Ashley or whatever, they always get taped all the time. Then at least I know I'm dealing with equality. I don't have one, and because my planes are all equal span, now I know everything is equal all the time, and now I can trim the plane. I'm not dealing with, well, this flap is a little bigger, or this is a little longer, or this is... That adds more complexity into the trimming. You're sure you can trim it, but this way is a lot easier. And this way, I've never found any way to improve on this a whole lot. It goes quick, you get it right all the time. Equal panels, taped hinge lines. Now you can really, really work on that yaw problem. You can start taking tip weight out, putting tip weight in, take tip weight out until either one of 2 things. It just drops a tip, and I would say just allow it to drop a tip just a tad, and at the top of the hourglass that it's perfectly solid. There's no soft spots. Overhead 8, solid. Now you know you have the tip weight right. You've dialed in one of the variable factors, and this is exactly how I would suggest anybody do this. There's really not a lot of room to invent anything here. This way works 90% of the time for 90% of the people. Another factor that can be deceptive is having more than a normal amount of motor offset. Now, there are reasons, and there are designs. Paul Walker's P-51 has an incredible amount of motor offset. The Chinese planes typically prefer a lot of offset. But I think, in my case, and for the designs that I'm commonly flying, 2 degrees is about right. The way you measure 2 degrees accurately is when you build a plane and you're bench trimming it, and it assumes you have clamped motor mounts, not holes. If you have holes, you've got to Dremel the holes sometimes, is you take a prop, a 13-inch prop. Let me show this up. This is really the only way I know to get it exactly right instantly. The prop should be a 13-inch prop, which means this blade is 6.5 inches long. You take a pin, an ordinary pin, and just hot stuff it to the end of the prop blade. Cut this prop blade off, because it's an old prop, hopefully. If you didn't have a prop, you could use a piece of plywood, a yardstick, but 6.5 inches long. Let me get back on the screen here. Now what this allows you to do is you put the prop with one blade on the plane, you measure this dimension parallel to the fuselage, then you spit and you measure from the pin to the leading edge. Flip that over. A lot of times you'd like to make a piece of balsa wood is good that has a little notch for the leading edge and maybe some scribe lines, and you could lay that in there, figure out where one side is, flip it. And that's why I like to have, see, a lot of times props don't sit on the, especially the older props, they sit crooked. If you have a one-blade prop, you've eliminated that factor. Now when it's on this side, this dimension here should be whatever this dimension is. Let's call this x. And this should be x plus roughly 1/4 of an inch. Between 1/8 and 1/4 are the numbers that I always wind up using. And even after thousands of flights, I'll go and check it, because most of my planes now have the clamps, so I leave the clamps loose. I check, I make sure I just put them hand tight, get my 1/4 inch in, and tighten everything down. And that really works well with the clamp mounts. So I have a roughly 1/4 of an inch. Another thing it allows me to do, without opening up the holes in the motor and butchering up all these $400 motors, what it allows me to do, I can set the horizontal just gradually, and there's a real easy way to do that with a razor blade in the back or the front, if I want to try a different dimension, so that the motor would have some down thrust or up thrust. Well, I could just loosen the clamp, stick a piece of razor blade in there, and I know, well, I would have one flight before I would know if that's going to be the cure. If I have a plane that's crooked or a plane that's been repaired, that's always a way to do it. But that x plus 1/4 is always a good dimension. Now, what that assumes is these two dimensions work together. The 2 degrees of motor offset assume you have some, and you can figure it out on your own, because most of my planes, not including the B-25, have what we call an Al-Rabi rudder, and it's infinitely adjustable. So that gives us another trim factor. But I always start, if I have 2 degrees of motor offset, what I wind up having is about 10 degrees at the rudder. And this every plane is different. But when it returns to neutral, it returns to almost neutral. So I have a throw of about 10 degrees, and that's why I have all these infinite adjustments on. But if we were discussing adjusting a Rabi rudder, I would think Al-Rabi would probably be the man you want to call anyway. So you have these two working in coordination. Now, if you have way too much motor offset, the plane's going to fly around not tangent to the circle. If you have way too much rudder offset, it's going to fly, and it's going to induce a yaw. So you really want to get, what I think is important, is get ballpark dimensions on everything before you even fly the plane. Always an easy one to figure out. It assumes that you have a straight trailing edge. A rake forward trailing edge, you'd have to make slightly different calculation. For right now, 99% of the planes have a straight, untapered trailing edge. You'll always know where the CG is. That's real easy to find. That's where the plane balances. Now, a good way that I've found to start this is when the plane is ready to fly, like a bench trim, or if it's a check after a plane has hundreds of flights or been retrimmed, where the lead outs come out of the wing, and this wouldn't matter if you have a 6-inch belt crank or a 3-inch. I would want to measure up from where the CG is, and let's call this dimension X. X would be the CG to the hinge line, and then I'd like to measure up to the mean average point. Mean average being, take the front one, take the back one, figure the middle, and measure that middle. It's the mean average that seems to be the most dominant force. That mean average should be, most of the times, X minus 1 inch. That gives you 1 inch of lead out rake, which 90% of the planes are going to fly with this. Now, we're not talking about if you're some superstar flyer and you have some secret formula, and now a lot of people like the rake more, like it, but the new guy, the guy that's trying to trim a plane for the first or second time, this dimension is going to get you in the ballpark all the time. As you move these lead outs forward, the plane is going to get more sensitive. As you move the mean average point of the lead outs back relative to the CG, it's going to get more stable. Now, the scenario that we're dealing with here, yaw, when it's yawing, there's a good chance this is going to be X plus 1.5 inches. So you'd want to start, before you start curing these other problems, get this to be 1 inch. 1 inch of mean average lead out rake. And I think having that 1 inch of rake minimizes or makes possible a reasonable amount of yaw. Now, I don't think you can ever get rid of all of yaw and make it perfectly yaw free, you might not have enough line tension, and I'm a believer that the plane should feel like a rock on the end of the lines, not a feather. But there's a relationship here between the rake of the plane and the yaw. You can always, for your own information, take the plane, mark where the lead outs are, and you're trimmed real well, and you're happy with it, and just slide them both all the way back. Fly the plane, and if it yaws, you've just learned something very significant, something you can put right in the bank. Now this may be one that gets into the area of, get off of my table, this bird. This may be one that you're not really familiar with, but believe me, this is the way it works. You have a plane, well, let's make it a nobler just for lack of, or whatever. Make it easy to understand this. All these factors interrelate with each other. The prop diameter and RPM. Now just give you an example. A nobler was designed to have a 10.6 prop, basically running about 9,000 RPM, I think would be. Now, this creates a stabilization gyroscopic effect on the plane. That's a tremendous force. If you go to a 10.5 inch prop by 9,000 RPM, the plane is going to be more inherently stable. So what happens is maybe when it's more stable, you could move the CG back an 1/8 of an inch, a 1/16 of an inch. What happens if you go, let's say you put a 46 in a nobler, which many people do, you can run an 11.6 by 9,000 RPM. Wow, you probably, in essence, have gone up about 50% in that gyroscopic factor. Well, now you might be able to move this even further back. Now, it works this way. If you were to put a real high-pitch prop on, let's say you put an 11.8 on, and you ran it at 8,000 RPM, I'm just making numbers up. What's really happened is you've reduced that factor, and you may have to make the plane more nose heavy. Now this is what happens when people retrofit planes with 4 strokes. If you have a pipe plane and it was running 10,000 RPM, and you put a wooden bigger prop on that's bigger but lighter and turning lower RPM, a lot of times you've reduced this factor, and a lot of times it's the opposite when you've gone from having, say, a standard motor to a pipe motor where you have a carbon prop that's turning at a higher RPM. It's the RPM. I would factor in the weight too, the diameter, the weight, as being a factor that you want to deal with when you're trimming the plane. Now, if you have a light plane, you probably can get away with a smaller diameter prop. Heavier plane, you're going to want a bigger prop. But it's always a factor you have to deal with, because that factor, the diameter of the prop, is going to determine how much rudder offset you need, how much motor offset, how much tip weight, and where the CG can be. The prop possibly is the dominant trim factor you have to deal with. Now, a lot of times you have a good example is we've had Miss Ashley with a 13-inch 3-blade prop. Boy, the corner is really tentative. You really have to hammer it. Well, you can move the CG back a whole lot more, though. You can put tail weight in the plane even, because that prop is doing the stabilization instead of the airflow. So a lot of times, if you know what the factors are, you can come up with your own formula. A significant thing. Big props always seem to equal more yaw. When I had the 91 in the Typhoon, and I was running 15 and 16-inch props, the yaw was unbelievable. You almost didn't need tip weight, and you almost didn't need a rudder. You could get away with it because the prop was becoming the dominant force. And you certainly, with a 16-inch prop, you don't need any motor offset at all. The scenario would be the smaller diameter prop, the more offset you might need. Bigger prop, you could use less. Again, if you know how that works and you understand it even a little bit, you got a real good choice of these allergies are really killing me, by the way. I've been to the doctor 3 or 4 times already. Knowing which way to go and knowing what to try is always a whole lot better than not knowing at all. And we hope this video is going to help in some way to have you have a basic understanding. Now here's one that always makes me crazy. A lot of people have either no understanding of this or very little understanding. The way, when this plane is flying tangent, and remember it's flying in a circle, let's put that center line right down the plane, it always would be flying just a little off tangent, so it would create some tension. But think of what one of the choices here that you have, and we're going to do this within the next couple of days, I don't know when. People that make wheel pants, or the flat wheel doors, the little wheel like covers for the retractable gear. What happens if these are on crooked? Or you make wheel pants. Picture what happens if you have a wheel pant out here and it's canted in just a little bit. Wow, is that a trim thing that'll make things wiggle and wobble? And that you may as well put the rudder on crooked as do that. Another factor is the further out into the wing the wheels are, the more significant or the more important it is that they're perfectly straight. Even if this is off 1 degree, it's a rudder. If it's off this way, it can really make you crazy. If it's off this way, there's a good chance you're going to have trim problems that are very, very deceptive. So the first thing we always do, and we're going to do this for Mike Kajeski again, we have a set of wires. We've flown the plane last week. We flew it. We got the plane to track and land and everything the way we wanted it to. And we have all his angles, everything measured out to 0. But what we want to do, we're going to lay a yardstick across the plane and make sure the 2 landing gear wires are in dead alignment first. That's step 1, and we've already done that. Because otherwise, if one wheel is pigeon-toed out, pigeon-toed in, or if you're from the front, you look and one is up, and there's all kinds of crazy things. Plane won't roll right, it won't land right, it won't track right, but it really won't fly right either. And what you'd hope to have, if you could plot this out with a laser maybe, is where you're standing 70 feet away, you'd like to have a straight line that went right through one wheel hub, right through the other wheel hub, and out the other end in a totally straight line. And these would be perfectly tangent to that line. Now, we've been able to do that in getting the wires on, but a lot of people put the wires on and then they get loose and they CA them or hot stuff them, they're crooked, and they wind up with crazy trim problems. So when we actually go to make these later on in the week, we're going to make sure we get them exactly 90 degrees relative to, this is now our reference point, and we'll put some of this on video maybe. But these can be a trim factor that'll make you crazy. And the way I knew about this, let me go back through this one more time. Years ago, Bob Hunt had an invention, if that's the right word, or something that I think Duke Fox had invented, that was a tab out here that looked like a rib that stuck out in front of the wing, and it was called the DF gate. And that was supposed to create line tension all through the pattern. Well, I remember Bobby having this on his plane, and I remember at the end of the thing that he didn't have it on, so I kind of wasn't real happy with that. But I went home, and I think that was 1980, and I looked at what would be the logical way to do this. Would be where the CG is, and of course I had a test plane. I wrote about this in Flying Models, by the way. There's a whole article somewhere in Flying Models in that litany of stuff that I've written. And what I did, I put a rudder that was equally in front of the CG and equally in back on a test plane and set it at 0. And what happened, as I cocked that rudder off, and it was adjustable with a little ball link, the plane had more and more line tension. It had enough tension that by the end of trimming a plane, you didn't need tip weight. You needed very little. Probably you got it down to 1/8 of an ounce or something, just to offset the weight of the lines. But what was happening, this was acting the same way the rudder does, or the same way the motor offset does, the same way the line rake does, and the same way the tip weight does. This was acting as a tension enhancer. Now, if I go back and look at that article, the only problem was that was on a plane that looked like a jet. And what happened, where the CG was, I had made this adjustable rudder up here, half above, half below, like a wing. And the idea was, wow, in the overhead 8 it would act like a wing. I had all kind of ideas. The only problem was, it really was two things. It was really sensitive to trim. In other words, one turn on the ball link and this would go to having pull your arm off tension or no tension, because it was in a very, I guess, aerodynamic spot it had enhanced airflow, as Dave Downey would say, just like the B-25 benefits from having airflow that goes over the wing instead of over the body. A twin engine always has a little more lift for a given amount because it's going over the wing and not the body, in theory anyway. But this, I didn't go any further with this because first of all, it didn't look, it was kind of not the way I wanted it to look. I don't know, I guess you could design in some kind of rudders here or something. It'd be worth experimenting with that. But even more, I learned that if you move this area out here and put that piece out here, and if you look at the MiG had these pieces on it when it flew at the Nats, and you could offset these a 64th of an inch. It worked the same as if you offset these an inch. So the further out on a wing that you could get this trim device, it would act with more leverage. I eventually didn't want to have this on a plane because I started building planes that were more semi-scale, Tsunamis and Stregas and stuff. But if you had a plane that you were just experimenting with and you weren't concerned with the appearance of that, or you could blend it into your design, it'd be worth moving forward on that. This was a very interesting thing. But the biggest one I learned was you have to get those wheel pans straight. You have to be within the parameters on everything to trim a plane to start. Then you can fine-tune it off in any direction you want. Just some final thoughts, and these are things that I've thought about and try to boil down to their simplest essence. Just rough guidelines. These would not be a be-all, end-all, a rough guideline. You have two identical planes, and let's pretend they're Brodak Cardinal kits. You build two. For whatever reason, finish-wise, whatever, one comes out very light, one comes out heavy, and you want to trim them, even though they're exactly the same plane. Well, they're going to probably trim out just a little bit different. The lightweight one is probably going to want more offsets. More offset being more motor offset, more rudder offset, more tip weight to create line tension. The lighter the weight. If the plane weighed 0, line tension would be 0. The plane weighed a pound, line tension would be, you can figure this out. As the weight goes up, line tension goes up, and you need less and less of these offset factors to make trim. Up to the point that the plane gets too heavy that the wing can't carry it. The lift of the wing can't carry the weight. So there's a limit to all this. So what you want to try to do, of course, is wind up right in the middle at some happy medium. Typically, if a plane is relatively light, it's going to have to fly fast. Look at any of the really light planes. They usually fly just a little faster than the ones that are a little bit heavier. And these are not always, and it's not a contest to find if you can find a rule that never gets broken. You try to help the most people most of the time with simple rules everybody can understand. You'd always want to fly a little bit shorter lines. You could get away with, let's say in the case of a Cardinal, Brodak Cardinal, you could use a 40 instead of a 46. If you were going to use a 4-stroke, you could use a 40 instead of a 56. You could take advantage of the fact that the plane was light. That would also mean, this factor would mean you're going to wind up using a smaller prop, which would be to your advantage. And you'd always then want to wind up with the CG more forward. See, each one of these affects the next one. And that's great. Because now you know, if you know this side of the equation, if you have a kind of a basic understanding of roughly how this works, and these are the questions that I get asked most often. Gee whiz, windy, my plane came out 5 ounces too heavy. Okay, we probably will need a little less motor offset, and you might need none. At some point in time, you won't need any offset. You'll probably be able to fly slower because the weight of the plane will make enough line tension. What happens, you can fly slower and slower and slower to the point where it either has not enough line tension or the wing isn't making enough lift. If the wing's making enough lift and you have line tension, you'd think you could fly 1 mile an hour. You'd be able to, with a little bit heavier plane, fly longer lines. You'd probably be able to, or definitely want, that bigger motor, let's say a 46 instead of a 40. You'd probably want, because the motor is bigger, again, you reverse everything here, bigger prop. And you'd probably want the CG a little bit further back to take advantage of the fact that you've already got plenty of line tension. You've already got a bigger prop, and what a bigger prop is going to allow you to do is when the plane corners, it's not going to slow down with a bigger prop. So you can, when you see a plane that has that terrific rotation, you see a plane that comes down and it kind of does that. Well, what I try to do with my planes is get them that it looks like they come to a spot and rotate. And that comes from a lot of things, but number one is having the weight a little heavier than the lightest plane you've ever built, but not so heavy that it's terrible. And when I flew Mike Kajeski's plane, the red and yellow one, the last day we were out flying, his is just about right. I think it's about 62 ounces, and it's just right. It comes around to a turn when I was flying it, rotates and turns. When he was flying it, he was over controlling it. We're going to make him a special handle. We're going to make him some wheel pants. We're going to do some maintenance on the plane, some touch-ups. But I really hope that this information is a big help to a lot of people, especially the people that are building profiles, building basic planes where they want to have some do's and don'ts, some pluses and minuses. This is real-world information. You don't need any calculator. You don't need a computer. This is how I found it to be in my 51 years of doing this. And I think if I can pass even a little bit of it on, then making these tapes is certainly worthwhile. So I hope that information serves everybody well.
$75 and $273.
Okay, that's the secondary bonding resin, right?
That's the same stuff you had. And then,
okay. And you got the rubber molding.
Got that.
Mold Max 30.
Got my Titleist Pro V1s.
Okay, yeah, we're not interested in golf right now. Where's that Fuselage? And you got your Rojet 65 side exhaust?
Yeah.
Well, this is the one we made on Dave's last visit. And we didn't know if we were going to be happy, but a Nomex worked out great.
It's perfect. I just got to put the fiberglass in there.
Well, that's nothing.
No, that's
I
easy.
could do that in 5 minutes.
Sure.
But you don't want to do it when it's not in a mold.
Right.
You want it in the mold.
Right.
As a way of...
Right. But it trimmed out nice. The spot we had where we tacked,
yep.
We lost this where we glued the... Remember when we glued the...
Yeah.
Glue spot?
Doesn't matter. The whole thing's coming off. But and you reestablish your center line on there. Now, what did you do as far as the crutch? That's the original crutch you put in there.
I gotta pop this out, but when I sanded this down to fit up in here, I've sanded such a curve into the motor crutch that it's getting thin, and I think
where is it getting thin?
On the inside here. I'll show you. When we pop this out, I'll show you.
Well, when you're done, we'll make a mix of carbon fiber and glue and fill that in.
What I want to do...
Because you're going to put threads right into it.
No, what I want to do is I want to carve this one to fit, and then make a mold.
Okay, you can do that. Sure.
So now in the future, anybody wants one that fits this body, you don't have to go through all of the work that I did to get this thing to fit.
Okay, so you just turn this one upside down and you got it.
Right.
Okay, that's
reasonable. What I want you to do is, if you got a chance, lay this up Tuesday or whatever and make a mold to make crutches with the curve already built in them that fit this body.
Right.
That's all.
Okay, that's no big deal. Just pull that out and we can do that. I like the fact you're not going to need formers in this fuselage. Wow.
No, this is nice.
Or at worst, you're going to need where the formers that hold the take apart.
Literally.
This is the only bad spot. Yeah.
Well, but
you use Aeropoxy light?
Just went in here in no time, and it's perfect.
Oh man, that's going to be beautiful.
There's nothing wrong with this at all.
No, that's a usable part. That's going to be fine. Now, okay, if you pull that crutch out,
I just need to pop it off with a knife or something.
take a blade. What'd you hit it with, CA?
Yeah, I just hit it.
Okay, so just break it. Let me see before we make the mold for that. And you've got the alignment now? Are you happy with the alignment?
No, it's not even right yet.
Well, what you ought to do is get it right.
Oh, I get sick and tired of sanding it.
You know what I'm saying? What's the point of making it that it's not right?
No.
Okay. Well, let me tell you something. When you put that in with secondary bonding resin,
It's never going anywhere.
you'll need a jackhammer. You won't be able to get it out. Boy, that Nomex looked great. That really worked out well.
Yeah, see the way this is getting so
Okay.
thin back here? See the way it's,
Means
just
nothing.
sand it?
Means nothing.
Well, what I was thinking is we could get all the curves in it, and then remake it by adding a piece in here, bringing it up.
You could do that. You could put this in a better way.
See, look, it just broke.
You don't need that. But this, when you're done, there's going to be bulkheads here. That doesn't mean anything. You could cut this down to where this is 1/8 of an inch here, because you're going to have a bulkhead here.
I look at that and I say, boy, I remember how rigid it was when I started, and now it's a piece of Swiss cheese that moves around.
But when you glue it in and put the bulkhead where, you know, in the front down here and the one in the back, no way. No, I don't. I think that's you're just in overkill mode there.
I'd rather be in overkill mode. I mean, there's nothing left here. Absolutely nothing.
Do you know how strong this is right here? This piece right here, relative to a piece of wood, it's 50 times stronger. And the only reason you can twist it, you made a 3-sided box here. What you could do is machine this down 1/8 of an inch and put a piece of 1/8 inch balsa cross grain.
That I could do.
Put cross grain balsa, sure.
That would be.
But you'd have to do it in a milling machine. You can't do that by hand. Dave, trust me, when this is in one piece and it's glued into this material, there's no way you're going to move that. Just the glue itself along here is going to be a significant thing.
Oh, this has to be fit. This isn't. I just got the motor, so the motor can go on there, and then we can fit it. But it's pretty close.
Here's what you got to do. You got to fit the motor into this crutch. Right. I think you're getting the horse ahead of the cart. Take that crutch out.
Yeah, the motor's got to be fit into here.
Get the motor in, drill and tap the holes. Put the bolts in. Then you got to make fake doublers out of 60-foot plywood, out of anything, just so you can line this up. And then you need to glue. Then you need to glue this in so you have a parallel line.
Right.
And that parallel line you're going to work with to set the wing in position. But Mickey Mousing around this, when it's in here, you know you've got two parts that when they're together they're going to be 5 times as strong. And don't forget you got a tank floor to put in there too, as if that wasn't enough.
Tank floor.
No, the other side, to complete the box.
No. Then I did this upside down. I got this.
No, that's the right way. Just what you got there is
I
fine.
need a tank floor.
When you have the tank here, aren't you going to have another piece in here?
Oh yeah, sure.
Okay, well that's the point I'm making.
No, that's fine.
Yeah, if you wanted to, if you want to hold it, that you hold this in your hand, that it's rigid. But when you put it in there, it's already going to be more rigid. You're like, if you know how strong this material is, when it's all put together, it's going to make you crazy. You're going to say, what the heck? This is plenty strong. This is stronger than the one that's in the Typhoon with a 91. In that one, I cut all this material out, and it's 2 inches shorter and everything. But it's only an 8-inch nose. So, I think mount the motor on there and drill and tap the holes. You got a 440 tap? Where's the motor?
I didn't bring any of that with me.
Because I don't have a good tap. I got a
beautiful.
Bupkis tap. Okay, it's a side exhaust.
Yeah, the motor's beautiful.
Okay. All right, but the first thing is you got to set this in, drill and tap the holes.
No, I haven't even had this in here yet.
Okay.
Which is...
What we did, we put some tape on the crutch, some masking tape. He's got to allow for the clearance of the nose ring, which is...
No, I've got that, but this...
Okay. Which spinner did you use when you carved up this nose?
This spinner.
This spinner, okay.
This exact spinner.
Then that's what I need, because there's a little clearance thing in there. Leave yourself the clearance. Leave extra, in fact, because we'll make a carbon fiber nose ring. And now we need to just make sure you can mark these holes with... I took a ballpoint pen apart here. Mark them up. Let me try to hold
That's
it.
what you want, huh?
Yeah. Give me nice, neat dots to work with. Can you see it?
Yeah, but I'm old.
That's why I'm having you do it. Rich Oliver has little plates for sale
Yeah, I know he does.
that are real handy to do this, but obviously we don't have one here. When you got your machinist friend sitting with nothing to do, have him make one of those up for us.
God, it stinks getting old. Blind.
Yeah, tell me about it.
This is the bad one.
Yeah, because it's a side exhaust engine. Difficult to get the side that the... Okay. Okay, you got them marked? Okay, now we got to get the... Here's the thing, because the other side isn't straight, you want to make sure this goes in a drill press straight.
Oh, yeah.
It's going to be a problem because you got this ground down.
Well, that's not ground. This.
Let's make sure when we put this in the drill press, it's flat.
That sits flat.
Okay, gotta want to have it that
Well,
things
you
are
can
off.
come down and index the drill and just...
Get out of here.
No, I think you're fine.
Okay. Usually carbon fiber is pretty rough on drill bits and taps and things. Dave went to a meeting over in the city. He's going to be there for 2 days, in fact, and I thought I'd surprise him. I'd get the crutch lined up in here. So the first thing I needed to do on my sanding pad, and I did it with gloves because I don't want to get any of the sandpaper, any of that dust and cuts on my hand, I established a datum line. Now from that line, the way we've done this in the past, we're going to line up our motor mount crutch, and we're going to glue that in. Now that is also going to be our reference line for drawing a center line for the wing. Everything is going to reference off, where normally on a wood plane you reference off this edge, we're referencing off the bottom edge. So the first thing, of course, we wanted to start with a perfectly flat, straight edge. One of the things I have to take into account, because now I have these two perfectly flat edges, I also want to get the crutch in on a 90-degree angle. So I'm going to make up a little, what I'll call a template, for lack of a better word. I want to make up a little piece that'll become kind of a former, but with all four 90-degree edges. I want to make sure I have an exact 90-degree angle on this, and I'm going to be very careful to do this, that it's as 90 degree as I possibly can make it. So I'm using Wes's square, because this is just going to be a template. This really isn't going to serve any other purpose other than being a template. I'd like to get it right on the back. But maintaining 90-degree angles. And it's just ordinary 16th plywood. But I want to make sure we're true that everything is 90. Chickadooly is helping Karen do the laundry. Hey Karen, I'm gonna, if he helps you with the laundry, you know you gotta pay him. He doesn't work for free. Okay, so now we know all our angles are 90 degrees. No, I'm just double checking that every one of the corners. The part that hangs out I don't care about, but the corners that are going to be down on the crutch, that they're exactly 90, because this is going to get the crutch in, that it's not on an angle. Step is I took the 16th, it's 16th plywood, one with the primary grain going top to bottom, one side to side, because I want the extra plies. I don't want to just use 1/8 inch plywood. This is really a load-bearing bulkhead. I measured the rough distance, and I left it a little oversized in case we need to trim it. So now I'll wind up with what will be the bulkhead that's at the back of the fuel tank. I have this bulkhead laid out. Now I want to make an exact copy of it, minus about the thickness of a pen line. Same thing, I'm going to do it with 2 pieces of 16th plywood with the grain crossed, much stronger than ordinary 1/8 inch plywood, and probably pretty close to being the same weight. And then I want to put the bolts in place that will become the take-apart feature, so that our bulkhead will help line up the fuselage, and I'll already have this piece made. It'll just be easier to get the holes accurately if I do it outside the fuselage. Then I'll glue the main piece in. When this is dry, I'll have the bulkhead already made, and I can just put the 3 screws in, and I'm all set. I have the 2 pieces. One that'll be the bulkhead. These will get blind nutted together eventually when it's time to put the wing in the fuselage, but the only purpose for making this part was because it's easier to make this before we install it. So this part I can put away. That's going to be my bulkhead that'll get attached to the wing. This part I can hot stuff in place with just a few drops of hot stuff right now, and I'll do that with a square. Now I just have this tacked in place because I want to make sure I have exactly 90 degrees. Now I could just run a B to CA, since this is not going to be glued in until we actually put the secondary bonding resin in. Now any gluing that you do to a part that's already cured, you need to use secondary bonding resin. And that is not 5-minute epoxy and not, okay, that's good. This is secondary bonding resin. It's called Pro Set. And notice it says adhesive. 175 resin, 273 fast hardener. This is made to do composite parts. But you never glue a composite part that has a smooth edge. We're going to rough this up with 80 grit paper any way we can, a file. You never want to glue anything until it's got a rough and at minimum 80 grit sandpaper surface. As many sanding scratches and little teeth that you can put in here. I may as well do some of this off camera. I want to get as much of a tooth on that as possible, because when I put the glue in, I want it to be rather than 2 smooth surfaces, I want it to be like this, that I have an interlocking surface, and that's called secondary bonding. We're using the secondary bonding resin. It's real important to get the mixture right. It's 2.23. I'm going to mix more than I really need here. Another good trick, don't ever try to use 1 spoon, wipe it and put it in the other can. You're asking for trouble at doing that. Anyway, we'll have to do our little calculation here as to, we know the tear is 8. And then I need to, we'll mix a little more of this since we have plenty. Don't use the same spoon. Okay, so now we know we have 18, and we need 2.2 of 18 of the hardener. We know how much we need as far as the hardener goes. So we'll set the scale to that gram weight and take the hardener until we get and then as soon as we get it right, whoops, now see we've gotten too much there. We can pull some back, but don't put any of the hardener into the resin. Just keep scooping until we get exactly 2.2. Let's put a little more in there. Okay, we've got that ratio right. Now the trick is, I want to take an ordinary flux brush, and I'll do this, most of this off camera because it takes a few minutes. 2.23 to 1. I want to mix this up, and now we're on a time window of about 15 minutes, and we have to get this all jigged up, somehow confined, or in the worst of all worlds, just hold it over by the heating vent for 15 minutes and watch TV or watch what's going on in Iraq or whatever. But a lot of people now, when they get to this point, they stop stirring. Wrong. I'm looking at my watch. 2 minutes more will do it. I'll do this off camera, but 2 minutes of stirring. If you cheat on the stirring, boy, you get soft spots in the glue that never harden. Always give it that extra 2 minutes. Inside of this was done with bleeder cloth that has a tooth surface. So the first thing I want to do is get in here, get a good coating of this on here. Because again, once we squeeze this, whatever we don't need will come out. And in the worst of all worlds, you could sand or grind it out if you really were sloppy about this part. And the reason we know this will be an acceptable way of doing this, maybe there are better ways we'll discover in the future. Well, we know because we've already made several planes that have already been flown. One plane, in fact, is 2 years old, and have not had anything like a crack, a chip in the paint, anything that would indicate we need to reinforce that a little bit more. Now the next step is going to be take the crutch itself with the motor in place and the spinner back plate right in place. Get plenty of glue on this. Again, it's secondary bonding resin. That's the trick here. If you tried to do this job using what amounts to be ordinary epoxy that's made for another purpose, I don't think you'd have anywhere near the strength. This resin can be post-cured, and if Dave wanted to, we could run it over to the anodizing shop when the glue dries and post-cure it. Really, I think that gets into the area of overkill, but sure wouldn't hurt to do it. I'm even going to put some glue on here while I have this apart. Again, then I need the alignment part of this is to get this to be parallel to the back, and I'll constantly monitor it and babysit it while I'm doing that. The nice thing too about this glue, it's thixotropic, which means it doesn't drip and drool. Hey, get away from that! Get away from that, this bird. I'm going to thixotropic him. And I know when Dave gets back, he's going to be gone for 2 days, so if I get this put together for him, I'm sure he'll just be thrilled. Okay, now we have the two parts that we need. We know what the alignment should be. We have it roughed out on a ruler. Just a question of getting this in, checking all the alignment little lines that I've put on this. This part is holding it relative 90 degrees, relative to what we want. Main thing is I want to line up the spinner. Once I'm happy with the spinner alignment, then I can check with my ruler just roughly before I go any further. To see if I'm close, this has to come up just a little bit. Up just a little bit. This is why it's good to have extra time with the glue if you can. Keep the shop cool. Okay, now we've got it roughly in place. Now what we need to do is figure some way of holding this all together with some tape or a clamp maybe. Anything that'll just hold this together and keep our alignment. Is I fired up the heat in the house. Once we have this lined up, or almost lined up, I want it to cure as soon as possible. I can get in with some clean Q-tips and just clean up the inside, any drips or drools that we have, just to get rid of a little of the weight that we may not need. I put a piece of tape around the bulkhead, checked my angles, my 90 degrees, but now with the heat up, what I need to do, that's most important of all, is called babysitting this. I need to babysit to make sure that nothing changes. And I've got my mark on the ruler. And those mounts are parallel to yeah, I just did that. Now the good thing is, because it's carbon fiber, you don't have to worry about the vise putting a little dent in it or anything. I can hold that. Now the question is just let it dry. Usually within an hour that'll be hard enough that I can take it apart. Now I always keep the original batch of glue right beside the part because I want to know exactly when it's going to start to go off. Now it's going to start to go off in mass a little quicker than I have it spread out here, but it's still going to tell me when this starts getting hard that I have to come back and babysit these 4 positions. I want these 4 numbers because that piece that's in there now is parallel to this line, and then we're going to use this line, extend it down and line up the wing, and extend it down and make sure we have the tail in alignment. I put a couple little clamps up in the front just to hold the piece in. Try to maintain the spinner alignment from the original part, and I think that's going to be good. And I just think this Nomex in the back of the fuselage, not having formers is going to be great, but what I want Dave to do is put this back into the mold, and then when it's in the mold, put on the light E-glass, and put this bird in the mold and mold him up too. So as soon as we pull this apart, and that'll be tomorrow, we'll leave the heat up overnight so this will get a good shot at curing. And we should have Dave a nice little surprise when he gets back from his making $10 million in New York City. He actually went to a trade show. Hope he's going to come back with something cool. Tonight what I want to do, I got a little time, I wanted to make Mike up a pair of spats. Since he's been working double and triple shifts, I know he'd really appreciate if I could get this ready for the weekend for him. We were flying his plane and trimming it, and you really can't do the final trim till you get all of this, because if these are off, as I said before, even a little bit, plus it affects the vertical CG and it affects the parasitic drag. So we really want to get these done. Now if I can, I just need to pull these wheels off. Step 1 is, anytime you can, if it's at all practical, you'd like to fly the plane with the wheels and the wires, and make sure that the plane takes off nice, lands nice. Once you have that under control, you know you have all your angles right, front to back angle right. Now we can set about designing up some wheel spats. The first thing we want to do, I want to roughen up the wire. Just take a parting wheel and just make this scratched, etched, use 80 grit sandpaper, anything you can, because I don't want, once these legs are in place, I don't want them to turn even just a little bit and become little trim rudders. Getting a good solid joint here, the only way I know to get it is to get this area as rough as possible. You get as much of the wire etched as you possibly can. That's a really important step to getting gear legs that aren't going to be a trim problem later on. I were to do a test with these 2 legs, and I glued the spat onto this piece, and the other one I glued onto this one, especially if I didn't wipe this down good with some alcohol or some acetone. You get 4 or 5 times the grip when you can roughen that up. The rougher you can make it, the better. You don't see that part anyway. Sketch out what we want the pattern to be. And of course we can fine-tune this, adjust it as we see fit. Going to make it look very similar to Strega. To arrive at the shape, we're going to basically take some 64th plywood and cut up one side of the gear leg. Now what I like about this system, number 1, the gear leg sides are 64th plywood, so they're strong. They tend not to do this and warp and twist like if you only were to make this out of balsa wood. Also, the fact that it's a sandwich, we can put end grain up against the leg. You couldn't make this out of balsa wood with the end grain up against the leg. This is a really superior way of making a set of gear legs if you go step by step by step. I would suggest anybody, this is a way, and if you build them straight and install them straight, they're going to stay straight forever. What I want to do with the first set is I want to lay these out in such a way that the grain is going front to back. don't want the grain going side to side on the edge piece. So I can just lay these out relatively straightforward. I'm going to need to make two, one for each side, of course. But the most important part of this is figuring out that you have those plywood sides, and boy, that is such a nice feature. You don't wind up picking up a little stone, something that makes you crazy. I've seen a lot of the guys that do these with balsa wood. They go to circle burner field and hit a stone, hit a little imperfection in the field. Bye! Okay, so now we have the wire. We have our pattern. And we can tack glue the wire on. Now we want to make sure we get the wire exactly 90 degrees to this edge. I want to make sure that when I sight this, I don't have this like that or like that. So I want to put a little, just let me get this right up on the edge here, in fact, so we can hide some of this, hide the whole washer. Put that right about in the middle. I can just make myself a little guideline here. One of the trickier little parts to make, that when it's done it's real nice. Now, where's that CA? Aha! There is that CA. See, always be prepared, like Hakuna Matata. Now I want to tack it. I don't want to glue it, because I want to be able to adjust it when I get to the last tiny little bit. So one little drop. Let that kick off, then I can check for 90 degrees. This is tacked on, I can sight. Make sure I have this at dead 90 degrees. Now I'm ready to put the balsa wood, 1/8 inch balsa end grain, and it should in theory come right out to the top and make a perfectly flat surface. Objective here is to get the balsa wood to the end grain. Let's get a nice straight edge. You want the end grain right up on that piece of wood. And of course end grain on the other side. And you'll see our plywood is going one way, this grain is going a little bit different angle. The final piece will go straight up and down, so we'll have a nice matrix of grains, grain orientation. And just to make this easier to deal with, I'll just trim this off. Another side benefit of doing it this way is it goes together relatively quickly. Now see, I'm trying to get the grain orientation to be just a little bit different. I don't want to have all the grains going front to back, side to side, a little bit different. It gives us some free strength in doing it this way. Now we can trim everything off even with the plywood. Leave it a little bit oversized. Now the next step is I'm going to go by the belt sander and belt sander all these edges off even with the plywood. And already we have a piece that's relatively nice shape. We can check just to get a rough look at it that we like the look. It's going to cover the wheel, look kind of like a door that would be realistic. We need to drill a hole in here because pretty much what I want to have happen is I want the grain to go straight up and down if this piece is big enough. If not, I'll put it on a little bit of an angle. So right there is where I need my hole. And just by putting a little trim hole in there, allow us to get underneath. Okay, now I don't want all the grains going in the same direction. I can just break this off. Okay, that looks like it'll work fine. Okay, now all we have to do is trim that off evenly. Now we can just leave a little bit extra on there. Press it off with either a belt sander or a hand sander. Now, I always seal this whole edge with thin CA just so the edge of the plywood doesn't ultimately delaminate. Any little imperfections you could fill in with just a scrap, a chunk of balsa. And because it's plywood, it'll take very little finish, a couple of coats of CA, and we'll be ready to paint it the same day we make it. You know, fooling around here. Rough these out with the belt sander, and then just put a nice edge on it. You can hand sand the edge just to make it a little nicer looking than if it was just, I don't think any real plane would just have a flat door. And because you have a 64th plywood edge, very, very convenient. Now up here we need to put a little filler piece. In this case we just look around for a piece of balsa wood. Doesn't have to be any fancier than this. In fact, you don't even need that piece. And once that's finished and covered with CA, never even see that. Now I want to harden all these edges with thin CA. That's the next step. And I'll put the rubber gloves on before I do that because I don't want to get any more damage to my hands than I already have. But this is the part that really is, I think it really adds a little bit of strength to it. Get the edge sealed, it's end grain, so it's going to soak right in. Just wipe it real quick with a paper towel. Even that spot we repaired. Then the trick is don't keep the paper towel in the same spot too long. Rubber gloves will help you keep your hands from being glued to everything. And of course, once we're done with this piece, off camera I'll make up the second piece so we have a match set. Then we can move on to finishing them. But this seals the wood, adds a lot of strength. In fact, it lets me glue my hand right to the bottle. Can also rub on a coat of thick CA after we sand this, just to get all the spots sealed. No kicker at all here. The kicker will just make everything puff up. Okay, now once this dries, I'm going to sand it. Do the same thing with a couple of coats of thick CA. Build up a nice finish of CA on there. While this is kind of drying out, I get the other one made up. It goes very quickly. It goes in a matter of probably an hour. Well, the only thing left now is to get some finish on them. I'll brush on a coat or two of dope. And as soon as we bring we have the compressor up in the attic, I have to bring the compressor down. Shoot a couple coats of clear, buff it out, and these will be ready to put on the plane. this morning, I took this out of the vise, take the clamps off and see if this, I was thinking about this last night. What I need to check now, even though I babysat this yesterday like a mother hen, you never know if overnight something shifted. And what I did, I checked the glue. First thing, a little pile of glue just to make sure. You can't do this with a ball part. But with carbon, because we're going to do a final sanding, it's not a problem at all. Now we have, put this away. We have this dimension relatively nice. This I think is going to be fine. The dimension that we need to check, and I need to get my ruler out, I need to check the four corners. And we're right on the money. So, Dave, you're in like Flynn, baby. I think Dave will be thrilled to death here, to tell you the truth. Okay, so now what we have is, we've established the datum line and the crutch are both in good alignment. Both of them are fine. Now we'll take the motor out and we can look at making the tank box pieces in here. I can frame these up, clean up these glue joints. When Dave gets back, he'll just be thrilled, because I know this was an intimidating part for him. Motor in. Looks like a nice clean assembly, but I can get in here, clean up some of the glue that dripped down, and then I'm going to make the tank floor. The tank floor is the next piece that I need to lay out. There are a couple of spots in here I really wanted to just dress off before we make up that tank box floor. Remember, anything gets glued, 80 grit paper. Now the first thing I want to do is I want to get a piece of craft paper, or balsa wood even, and make up. I'm going to leave a 1/4 inch so we can shim the tank. I want to make a pattern for that tank floor. Now, of course, I'll use the tank itself. I also need to figure out, I can just use the fuselage itself here to make myself a pattern. Balsa wood pattern, just have a piece of scrap wood. I want to get a nice fit on this. We can move that back. Just rough this out. And then I'll have this as my pattern. Okay, now you just know that when I cut this part, I'll leave the incline on, and I'll have a nice press fit in there. I don't want to have a sloppy fit. What I'm going to make this part out of is ingrain balsa, and it's got a laminate on each side. You just cut this out from our pattern and then get a nice tight fit on it. Like yesterday, to mix up some of our secondary bonding resin, I won't go through that again. Get this piece glued in. And now we can put this aside to dry. I tried to clean all the extra epoxy off, but once this dries I can get in there with some sanding sticks and whatever, make that a little bit neater. Now, because we have the heat on in the house, having our landing gear legs up by the heating vent, we've got some silver on them. We need to touch up Mike's cowling. Mike's cowling had a lot of little bad spots in it. I just kind of roughed it out, put a coat of Brodak primer on it. We'll be ready to spray this. And also, while I have the heat on in the house, I can have our tank box. The heat will help cure that glue up. Of course, it looks like it's going to rain any minute. I already put a little bit of retarder into the mix. I didn't want to take a chance that this is going to fog up. Again, doing a little maintenance, at least for Mike. This is a relatively new plane. Just having some of these areas fuel-proofed and touched up will be a big help for them. And having a nice set of spats, of course. Then we can final trim the plane. We'll have the final CG hopefully on there. Everything is hopefully lately. And because it's Brodak dope, that's going to dry up relatively quickly. And anytime you have a little wooden part like this, and you're going to paint it silver, it's almost, paint it yellow, it's always a real good idea to paint it silver first. Use that for kind of a filler blocker coat. And then the yellows, typically you'll need one or maybe two coats, and the coverage will be fine. And later this afternoon, we'll get some clear on this, assuming it doesn't rain. And that's going to be a nice little set of wheel spats. Very easy to make, quick. Second day, actually, if it was a flying day, we could let these dry and go flying, because you could buff them out anytime, put clear on them anytime. It's a good way to make these little guys. Costello brought me over this video. There's one key scene on here. Look at this A26 footage. Nice A26 footage. I love this. Now this, of course, is a giant scale RC plane. But I'm looking at the shapes, how this is going to look when we make our final, I don't know, final version of it. Les Demmett's still been working on the plans. Unfortunately, he had an accident with it, but every time I can, I pick up some A26 pictures, photographs, footage. Really not crazy about having it crash, but just looking at some of the views, that really was some nice, well, right up to the crash, it was some nice footage. That was from Mike Costello. Oh boy, today you can hear the birds chirp. We're going to put some clear on Mike's cowling. Those wheel spats, Dave's done at the city. I have to go pick him up. We'll see what else we can get done today. It's a fabulous day. What a day for painting. Wish we had something to paint beside these little parts. After a second coat of clear, you can see that's really going to start to look nice. And as with most Brodak dope, there won't be a lot of sanding and buffing. We'll give this 2 or 3 coats for Mike. And we're supposed to be able to fly this weekend, but I don't know. We've had enough rain. But that's a typical job with Brodak clear. Let that dry. We'll give one more coat after we do some work on Dave's stuff. But boy, I think that's going to just dress up the plane, do the maintenance necessary, and Mike will be ready for the flying season. And what was predicted to be a really rainy day has turned out to be just a great day. Just amazing. An amazing day. Everything about this time of year is amazing. Yeah, Midgely's back from his meeting in the city. It looks like we're still going to get some flights before dark here. He's never flown this plane yet, but since he's building up a carbon plane, he wanted to get a feel for whether he's going to like this or not. And he has a Rich Oliver 65 bar stock side exhaust, and this is a 65 rear exhaust, but basically the same engine. Now, one of the things I always think is helpful, at least to Dave, since Dave is building a plane very similar to this, getting a little feel of this plane. This guy's now a year old. He's got a season on him. More or less to see if this has any potential for him. Again, last year we had quite a few people. Jose Modesto, Richard Oliver, people that got some gave us some feedback, got some flights on this guy. It looks like the weatherman was right. It's going to rain later, but we're probably going to sneak in a flight or two here before the rain comes. And even if we only get 1 or 2 flights, well, it just makes the workday go better. You can start off with a few flights. Somehow the rest of the day just seems to go a lot smoother. Now, we got this motor from Richard at the end of last year, and it's just been a flip and fly since then. I think the problem is, I think the handle is still adjusted to the way Rich Oliver had it set. I'm not sure. Anyway, after we have this flying session, we'll get back to the shop. See how Mike's gear dried up, how Dave's stuff worked. I don't know if we can get anything done tonight. That glue takes 24 hours to dry, that post-cure epoxy. Back home after Dave's amazing flying day. We're going to break in his side exhaust, Rojet 65. And believe it or not, it hasn't even rained yet. The sun's back out. Looks like Mike's stuff's all dried up nice. Oh, we're in Fat City here. taking Dave's 65 in. Bar stock 65. We're just about done with all a little work on the inside of the fuselage. This is going to have to dry overnight, and then he's going to have to do a little more trimming and fiddling. He's got his tank box in there. But these motors, every time I see one, they are really nicely made. You got to have one of these in your hand to believe the quality. Okay, with Dave's fuselage in the framed up stage, what we're going to do today, before Dave leaves, we're going to make up another crutch, because he has the mold up there to make another fuselage, and we're going to make one for Woody. But the first thing with these crutches, most important thing, get the material all cut the size, and in this case we can use up a lot of our scraps. We can cut these pieces, and I'll do some of this. Dave's over on a computer buying fish, I should say. What kind of fish are you buying?
We don't know yet.
He's buying fish off the internet while he's doing that. We're going to set up all the material to make another crutch, and this will be the basis of what will be Woody's second carbon aeroplane. He's mixing up the resin. He's got all the material pre-cut, all the little scraps cut to the shape that he's going to need to pack the mold. And it's always good to have everything right at the point where you're ready for it. We'll put a little black dye and give that.
What you need a vacuum. What you need is one of those bell jars.
Yeah, to suck out the bubbles.
This in, put the vacuum.
Sure. Well, we'll have one in the future. On this kind of a part,
yes, we will.
On this kind of a part, you don't really have to worry. The bubbles are all going to come to the top anyway. Okay, you ready? The black dye does it, just allows you to see where you have little coats of resin. You want to get in there, get plenty of it in there. Get up in all those little riblets too. Now what Elliot was doing and what I was doing. Giblets. Yeah, is just spread this apart to get in there, or pick one end up and twist it. Give it all, put something in the middle so you can fill those little areas with resin. And then you can start shoving the carbon down in there. There you go, however you can do it, because those are the areas that you're going to need to pack. Yeah, get plenty in those, the giblets. The riblets, the giblets. Russ made a whole bunch of crutches out of this mold already. I think he made about 5 of them. Let it like at least half, and just let it migrate out into those riblets. The giblets.
You learn a new vocabulary.
The riblets, I'll tell you, you teach a parrot one new word, and all of a sudden he's a parakeet. All right, pack that in, baby. Start packing that carbon fiber in there. Now the idea is to get some, vary the grain so it's not all going in the same direction. Some front to back, some back to front. Pack it in, baby. You can't play with them now. Get off it, Dave. Yeah, just pack it in there. There you go. Make sure it stays good and wet. Keep it wet. You can do it barehanded. Do it with this little tool is what I use a lot of. Get it in the corners, the edges. Since you're going to do a machine shop flat on one side, don't even worry if some of it's sticking up. You can use some of this scrap. This is what Elliot was using. Some of these pieces, just get carbon everywhere. Random shapes, and then put some of the long toe front to back. Just let it hang out the mold if it's oversized. Or we trim it off. Trim it off with the old scissors. Check these scissors out. These I would say these are slightly used. Use these. Give me my good. He's going to ruin my good scissors here. We go through scissors like hamburger meat at McDonald's here. Okay. Just pack it up. All you got to do is pack, baby. Pack-o-matic, and keep it wet. One of the more fun little projects. You could train a monkey to do this. Yep. There you go.
Hey, get off.
See, the reason for having all that extra resin in a mold is you want it to be wet right now. You don't want to pack that in there and it's dry. So a lot of times you can just wet it before you even pack it in. Run the brush with the resin down it. You can pack it in wet.
Here.
There you go.
Be useful. Cut the end of that off.
Scissors are like razor blades. Just double it back.
Yeah.
Yeah.
Don't worry.
You don't have to be fancy on the top because that's going to get machined down. Part where we start to separate the men from the moles.
The men from the
The men from the mice. Okay, just pack away, baby.
I'm surprised Karen doesn't like mice.
It's no more. We were sitting in our living room the other night watching TV, and a mouse ran across the door, and I thought it was like a terrorist attack. It was Karen jumped so high. Last night, Dave and I were in this fish place, and the guy had an arowana, and he was saying the arowana got so big he was feeding them mice. He's got a nice fish tank over in that place, so it's really nice. Pack away, baby. Pack, pack, pack. That's the way you got to get it packed. You can use it sideways too. Those little tiny areas. The more you can pack in there, and because we're going to machine the top of this, we don't even care about the top. We'll put a piece of Teflon over it, but it wouldn't even matter because you can put that on the machining table and just run a fly cutter across the top of it.
That's what we will do.
Did you notice how or you had your machine shop guy do it? Did it cut nice?
I did it.
It cut nice?
Oh, it's like cutting wood.
You can machine a nice if you run it slow. Jimmy, when he was doing it, was running the fly cutter really slow.
You don't have to run it that slow.
I mean, he would get a surface. It was almost like a polished surface.
Yeah.
It was really nice. Just pack away, baby.
I'm running it just a little slower than I would if I was machining aluminum.
Okay. We're celebrating Woody's 10 years of being a pit boss by making him a carbon fiber crutch. We're going to award this to him at the Nats. 10 years of having everybody at the Nats hate his guts. Oh, Woody Midgely, don't throw me out of the circle. I need to take pictures today. Oh, I'm so important.
Poor Woody.
Yeah, Woody is okay. He's an okay guy. Don't care what you say about him. So this is another day. They predicted rain all day, and it looks like it's beautiful out there. Well, we may get some flying this weekend.
Now, anybody who sees Woody at the Nats or any contest this year, ask him where the local Dairy Queen is.
He could be, like the donut guy, that Dunkin' Donut guy. He could be the
Krispy Kreme Woody.
Krispy Kreme. He could be the guy that tells everybody, oh, don't worry, you got health problems, just eat a lot of Dairy Queen. That'll help.
There's the DQ.
Yeah. Follow the painted line on the floor to Woody's DQ.
To make the next fuselage I'm going to make a wooden crutch and make a mold with all the curves and everything built.
You can do that, sure.
Yeah, I'm gonna.
Why not?
So you don't have to sand and sand and sand.
You don't know how long I spent too.
I spent hours sanding.
You think you're the only one that's a slave to the carbon world, the carbon gods here. But it's fun. Come on, you're having more fun than running that railroad. Last night, Dave got his license to run an O-gauge railroad. Ran the trains off the table. The Chickadoodle Railroad. Hey, by the way, you get anybody that already has seen, by the time you've received this video, our website should be up and running. kwrailroad.com. Our business is expanding into the world of railroad. Next, we're going to own a Rolls-Royce dealership. We'll be all set. All right, are you ready to put the Teflon on there? Paint the whole thing?
We're ready.
Let's put the Teflon on and put this puppy to bed.
All right.
Put the newspaper down first. You got here. Hold on.
Newspaper right up there.
Wait a second. You only need one sheet because this counter is relatively flat. Wait, we're going to do this the right way. Okay, lay that up there. Get it so it's flat. Put the Teflon on top of it. And go get some cans of thinner or something. Heck, you don't even need anything for that. It's going to get machined off. And when that cures up, you'll have another carbon fiber crutch. Now, you won't believe what we're trying to do outside. In fact, I'm trying to sneak up on Dave. He's trying to get tradition into this BMW, this little,
Easy.
Got it in?
I got it out. We can take the motor out.
Okay, yeah. Well, here's a blanket.
Right in and right out.
Dave is going to take this home for a little motor development. We're going to put his Jet 65 in here. All right, so let's take this downstairs, take the motor out. That'd be good. You got the motor still in your car? Where's your motor?
It's in the
and you know you can get it in.
Yeah, no, it goes right in.
Okay, and then you can run your Jet 65. You can get some break-in runs, get the tanks shimmed. That'll be a good exercise.
It fits in a BMW.
We originally were saving this so when Elliot came to this country, he would have a plane to fly right away, but it looks like that's 5-6 months away. And this is Elliot's laser engine in there. And in the meantime, until Elliot actually does come to the country, we can get these things going. We can get Dave's engine in here, and he can get some runs on it. And that's, by the way, that's a great idea, is to take a new engine and get it running in an old plane that you're comfortable and familiar with. Get the tank shimmed and whatever. That's really one of the things I would suggest before you take a new engine, a new plane, a new tank, new tool, and then try to sort it out. Just makes it a lot easier. This engine, we had a lot of good flights on. The only problem is the weight of the engine. It's 19 ounces, and it's heavier than a Sato 91. So at some point in time, you have to ask yourself, would it be better to just have the 91? And in my case, we were going to eventually try to put this in the Typhoon, but the 91 and the 72 have both worked out well in the Typhoon. So we're just going to save this when Elliot gets back here in the United States, and we've had enough time on it. We know it's a good running engine. It's a one-flip start engine, too. You don't even need the electric starter most of the time. Anyway, but Dave will get to do his 65. What was always nice about this engine is having this exhaust inside the body and having the carburetor right on the head of the engine, which that was a nice attractive feature, but the problem is the weight. It's just heavier than a Sato 91, and we've had the 91 in this plane, and I don't want it. It's already a heavy plane, so having brass tail wheels and the like is not going to be a real good choice. They call him Dave the Butcher. Oh, what a butcher! He butchered up tradition. Oh my God, what a butcher! Oh.
Can you turn that camera on?
No. Dave butchered it all up himself. He butchered up tradition. Heat and 5-minute epoxy to get the new tank floor in place. Just keep it good and hot until that floor gets solid, then we'll do the next step. And what we did, we got rid of the old blind nuts and we put in a brand new set of clamp mounts, even though this plane had some retrofitted clam mounts. Clam mounts. You can mount a clam up. So the engine actually will just be clamped in. It'll allow us to move it front and back, turn the offset, get it just how Dave wants it. I'm trying to think, is there any engine in production now that hasn't been in the plane? Do we have anything that... God, I can't think of any. Even the 4-strokes have all been in this. But the clamps are the way to do this. There's no... Now you have completely new threads, new screws. And even if you get another engine, you can... What do you got to do, slide it forward? This isn't gonna go. Somehow the holes are wrong.
you got to make some shims that, because this mount is so narrow and these are so long, it's going to want to bend the aluminum down when you torque it. So what you got to do is you got to put a couple of spacers that are just less
10 thousandths less than the motor.
less than the motor.
Like wheel collars.
Right.
Machine up some wheel collars.
So you just put them in there that are left so that it comes down, it grabs the motor, but it doesn't bend it in the center.
Yeah, that's a good idea. But even if this gets loose, what I found, nothing happens. The motor slides forward, hits the front bolt. It can never come out, is what I'm saying.
No, it can't come out.
It just, if it was loose, you could take 10 thousandths more off the wheel collar if you wanted to do that. But see, if you make these pieces out of a thicker aluminum, they won't bend. Or make them out of steel. The hell's the difference? A plane like this, it doesn't matter. Have a cup of coffee. You're getting old ahead of your time. You're starting to look like me. Chicky, he looks just like me, in fact.
All right, but for a rebuild, what I'm going to do here is I'm going to take a piece and bridge this across into here.
We don't need the 4-stroke hole now.
And I'll fill that all again and build this up. I'll give myself a back, build this all up on the front.
But all that is just cosmetic stuff. There's nothing there that's...
Also,
yeah, you could make it out of 32nd plywood, and then you'd have something solid to hook the,
Now what I want to do is think about how I'm going to get... See, this wall's pretty good. If I could get a wall that comes up all the way to here, I can then take this and put a new cap on it.
And let the back of it hang out over the landing gear. You can cover that right up.
Now see, what I'm thinking
Fancy it right up.
Is what am I going to do? What am I going to grab on here with what?
Well, put a little piece in here, like a lip sticking out.
Oh yeah, well that's easy.
Okay, so you have a little lip to work with when you do the cosmetic part.
I'm going to come up here so I can give myself...
Yeah, of course. And then I would take the motor out and just half-ounce glass the whole nose.
I don't even have to do that because I can put the tank in, put another piece of plywood in there, give myself a 1/4 of an inch.
Give a 1/4 of an inch for the shim. Put the tank in right now. See if it fits. You can make it the tank comes out the bottom if you want.
The tank?
Yeah. Fits right in, right? You could put a 7-ounce tank in here for crying out loud. Yeah, that's what's this. 6. That's what you need to run that motor. 6.
I mean, that doesn't move at all. There's no back and forth. There's going to be up and down, but there's no back and forth in that at all.
No.
Which is fine.
And we got 1/8-inch plywood underneath it.
The trick now is to get a plywood floor in here.
Just make the floor up, sure. Or use some of that carbon fiber laminate material that...
That's what I'm thinking. Just put that in there.
Sure. And then make a bulkhead back here. Complete the box.
Right.
And then if you want to put a V deflector, you want to put another well, that's all nonsense. It won't matter at all.
Yep.
Now what's funny, and I think about it often, is the life of our models kind of reflects our life. And here we are in 1987. Now just think back, 87. I had started my business, made my first couple of products, quit working for Ford and said, I'm going to manufacture model plane parts and see if I can last a year or two before I go bankrupt. So here it is, 15, 16 years later. Look at Todd Lee here. Todd, who knew Todd would grow up to be the gentleman that he is? Great flyer. Ted, years of service to Pampa. Frank McMillan, president. Jimmy, top-level flyer, one of the top levels of all that. Paul, of course, a legend. Who would have thought? How many things are in this picture? And who would have ever thought back then that this kind of an emotional moment to think about it as Dave takes tradition. Who would have ever thought 17 years later we'd be retrofitting a Rojet 65 into this plane? An amazing, amazing thing. It's amazing to think about the history, the life that we've shared. Old office back in the old house. God, I think about this. Who'd have thunk it? Look at my old phone here. Didn't even have a push-button phone back then. 17 years ago. And who would have ever thought 17 years ago I would have met Karen and we would have had this life that we've had with the fish and with Dave. And Dave's gone on to become a multi-millionaire owner of one of the biggest fluorocarbon businesses in the world. Driving BMW. Look at this. He's got the thing in the back. I don't believe this.
It fits.
Oh my God, that is so funny. 17 years ago, who'd have thunk it? Who would have ever thought that this would all come true? It's just like the history of the world, part 2. Mel Brooks didn't know what he was missing when he didn't do your life story. Look at that.
Oh,
Is that amazing?
too much room.
You could put another one in there. Look at this.
You know what? You could.
You could probably put two. This is an amazing car. It's not even, the thing is, it's not even a real hatchback, and the seat doesn't go down. So I think what's going to happen is, if I get as wealthy as Dave someday, and don't think that's really going to happen, what's going to happen is I think I'll buy the bigger version of the BMW, and probably could get 3 planes in there. I don't know. He's on his way back to New Hampshire. It's turned out to be a pretty good day, but we've had, as we always have, a week of adventures, a week of unexpected challenges, and probably the most fun you could ever possibly have with without going skydiving. Well, as you can see, all our flying plans have come to an abrupt halt. It is absolutely going to be another 6 to 10 inches of snow today. No way we're going to get to the flying field. Embarrassing. We thought the flying season was here, but fortunately we have another little project to work on. And it really is beautiful, but you know, I want to share this little project that we're going to be working on in the next couple of days. This is kind of neat. Now just check this guy out. This is part of the little setup that Carlos made. It's a VCR camera motor. The only problem is he needs a plane to fly. Because we're in the middle of a snowstorm, I guess we'll just, well, we're going to have to build him some planes. He's flying up against the mountain there. And of course, Augie Buffalano, our good friend, has brought his Corsair down to the field, but there's nobody flying stunt. There's only people flying invisible airplanes. He's really having himself a nice invisible stunt pattern there. Now we gotta go build some planes. We'll try to use this snowstorm as a little bit of break in the action. Doesn't seem to bother him when the trains go by. And if you were wondering, yes, I painted it myself. A nice little guy. I don't know. We're going to make some signs up for the field here so that we can give Mike Kajeski the credit for keeping the field nice and clean, as he does with the circles on the field. Now you may think by looking at this that this is really easy to do. Well, let me tell you something. Try making a little model of a plane. This dimension needs to be 1.5 inches to be a relatively scale, or a little less than 1.5 inches. Try carving something like this up out of balsa wood. Now we're going to obviously make more of these. I made 2 of these. This is going to be George Aldrich's Nobler. Of course, he's going to be flying on our field forever. I made a little Miss Jamie. Didn't get the lettering as nice as I'd like it. Try to capture the look of all the Candy Brodak colors. We're going to make some more of these because basically we're snowed in and we don't even have a phone line today. The phone line is down from all the ice. We're going to make some of these up. I think this will be a nice little good thing to do on a day because we're basically waiting for Les to come over, start working on his 40 ship, but right now he's in the tail end of the recovery and we're looking at maybe another week or 2. And we'll do a couple little details here, go shovel some snow, have some hot coffee. If you and by the way, if anybody out there would like to carve one of their model, I'll be glad to add it to my railroad. We already have named the field Cardinal Field. Carve this up, see how good you are. I hope Ken Clapson will carve me. Listen, Ken, this is for you because I know you're a really talented guy. This dimension needs to be 1.5 inches. 1.5 inch wingspan. Carve me up. I'll put them on my railroad as the Canadian contingency. Now, believe me, if you think I'm kidding, if you think it's easy to make these, just go make a few and send them to me because I need them for my model railroad. Actually, it could be John's plane too. I don't know what number John's is. Maybe John's is 1 and his is 2. Who knows? I think George would be happy to be out on the model railroad. Anyway, that little guy, they definitely are cool. I'm going to make a lot more of them. A good tribute to our friend George Aldrich, late friends. Making all these little people and little pilots and Miss Jamies and stuff. It's really made what was a stormy ice shoveling day. Turned it into something a little enjoyable. Now, what little airport would be complete without a few ringmasters? I think I made it too long. Should be a little bit shorter. And of course we put a 190 on it because that's the size of the dowels we had. I'm not sure I'm losing my mind. In fact, I'm probably definitely losing my mind. But it really is, it's doing a good job of taking my mind off the fact that our whole week is going to be shot with this ice storm. Oh, another day. Ice and snow. Ice and snow. What I'm blown away by, again, just how much time it takes to do this. Anyway, even George Aldrich's Noble has a little muffler on it. A typical ringmaster. He's a little bit too long to be a ringmaster. Mike Kajeski's out in the pits. Not sure who's flying, not me. Anyway, because it's another icy day, I guess we'll make a couple more planes. Anytime I want, I can just add a few planes to my collection here. Or if worse comes to worse, you can just go fly a kite. What's totally amazing to me is how many skills and things that we use and just as you take for granted in model aviation that just you can transpose right into other things. One of them example, of course, the model railroad, but certainly in other things where painting, sanding, finishing. In Dave Midgely's case, they were doing some model cars with the Boy Scouts and he found that all the skills he had and the Brodak dope and everything just worked perfectly. So amazing, but because we have another inclement day, I guess we'll add a few of these little guys to our Air Force. And as the final day the storm comes in, look at this. Is that cute or what? I even made little landing gears for it. I don't have them installed yet. So next time you get a big snowstorm and you have nothing to do, make me a B-25 for my train layout. We even got a Brodak dope finish on it. I don't know about you, but I think that's pretty cool. All that's left to do is install it on a layout. Notice we're on 6-second laps. And of course, because it's such a nice day, in real life it's raining and it's icy outside, Mike Costello has shown up with his ballerina. Elliot Scott's shown up with his Brodak Cardinal. Joe Adamusco's here with his Spitfire. And Mike Kajeski's here with Miss Jamie. Mike's got to mow the grass though before we're going to let him fly. And of course Wendy's flying with his Zetron, flying left-handed. If only that were true. So it's been a fun little project on a terribly rainy day. Terrible day, period. And who said you can't have a contest in the middle of the winter? We have really had some fun building this train layout. And adding this little vignette to it, it's been great. And it's amazing how many, again, modeling skills that work in model planes. You can transfer them right over into other things like model railroading. Now, who says we never go to VSC? Thanks to Bruce Hunt, we're watching Lou Walgas fly here right in the beginning of the video. Anyway, this is from Bruce Hunt, who has some videos of VSC for sale for $15 plus shipping, $4 for shipping. And they're very, very good. He's got the pilots all identified. The commentary is excellent. The footage is actually good. And I think if you can't make it, even if you are at VSC, it's always nice to have the footage. This is Bruce Hunt's Impact. We've shown that before. Bruce, of course, the defining feature of Bruce's and my friendship is we both have birds. He's got Gracie, and I have Chicky. Nice Impact, beautifully painted. Now here's the information. It's www.heavystunt.com. bhunt@Southwest Bellnet. Of course, all this information is in Tampa. Bruce's business card is pretty cool too. In fact, look at the little icon he's got up here. That's cute. Very, very nice. And we have enjoyed the video, and we'll, anytime the guys are in the shop that haven't seen it, from Bruce Hunt, Bruce, we really appreciate it. And I mentioned this in Stunt News in the next issue. I hope that'll give you a little plug. Get a few sales for your upcoming video business. Now, after watching Bruce's great video for several times, what I wanted to do, I wanted to put a couple minutes of it's the appearance judging part of the video, because this is the time of year a lot of people are looking for ideas for new paint jobs or some inspiration for new projects, including us. So let me put a couple minutes of this. This is the appearance judging at VSC, and it's some real nice stuff. Bruce, thank you very much for this footage. We really do. You know, we never get to go to VSC. This is our busy time of the year, but believe me, I really appreciate this footage, and I hope you're going to sell a lot of these videos. This is a great job.
He could almost just bring it up. I don't say exactly what easily have designed it. It is off scale. Yeah, because he is the cockpit. I mean, there's a full-on 3D cockpit. Very well done. Not all the airbrush, and even underneath all that, quality scale landing gear. Flies the pattern very well. No, I saw it fly today. I just never saw it up close. He did it. Did you? Oh, that? My side. Those yours. airplane there, I can have it.
That's a pretty one. It really is. It's pretty.
Pretty flawless.
Hinge lines are really tight and well done. It almost looks like it hadn't been flown.
Yeah.
Too pristine, doesn't it?
It looks like it's just right out of a factory mold.
Yeah.
It looks like. It doesn't even look like it was put up from Boston.
It's got a double star muffler on it. There may be a double star in there.